Here we are again in West Virginia, and I've got Ellie with me because Ellie is great at delivering jokes.
I can't seem to escape this.
All right, Ellie, are you ready?
What's the difference between a piano, a tuna, and a tub of glue?
I don't know.
You can tune a piano, but you can't piano a tuna.
But wait, the glue.
I knew you'd get stuck on that.
Yeah, get out of here, kid. You're stealing my show. Thank you, Ellie. Okay, well, we're not going to get stuck on glue. We're going to get stuck on factoring trinomials. So let's take a look here at factoring trinomials where the leading coefficient is not a 1. Now we've looked at examples that didn't have a leading coefficient of 1, but recall the examples we looked at before, we could divide out that common monomial, and once we divided out the common monomial, there was a leading coefficient of 1 in order to set up that double parentheses. Well, now what's going to happen is we're not going to be able to do that. There's no way to create a leading coefficient of 1 in these examples. Now, when that's the case, now remember, always, 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 first, do that common monomial factoring. Always look to see if there's something common that you can divide out of every single term before you do anything else. But then once you've done that and you're ready to take your trinomial and set up that double parentheses, if your leading coefficient is not a 1, there are different methods to do this. Now, I'm only going to show you 4 methods. There are other methods than the 4 that I'm going to show you. These are just the only 4 that I really am very good at. So these are the only 4 that I can show you. The first method that I'm going to show you is what's called guess and check, the old guess and check. Now what happens with guess and check is you just keep guessing, you keep playing with the number combinations until you get the right number combination. Some people don't like guess and check because it takes a little while. And there's a lot of guesswork involved in it. That's why it's called guess and check. But those who do guess and check get very good at number sense. Back in my day, this is all we had. All we did was guess and check. But we were very good at number sense and how to create number combinations. Now, for those who don't like guess and check, another option is factoring by grouping. What factoring by grouping does is it takes your trinomial and it takes that middle term and splits that middle term into 2 terms, and it creates a 4 polynomial. Because when you have a 4 polynomial, we looked at this before, you can pair up the first 2 terms, pair up the back 2 terms, you can factor each of these pairs and create a common binomial. Remember that common parentheses. And then you can divide out that common parentheses. So factoring by grouping is one that kicks back to something that you should already know how to do. Now, another method that people really love is what's called the box method. Box method starts like factoring by grouping because it takes that middle term and turns it into 2 terms, creating that 4 polynomial. But what happens here is you do not pair these up. You take the 4 terms and you put them inside of a box. And then what you do is you factor across the rows of the box and up the columns of the box, and your answers are sitting on the outside of the box. Now, frankly, what you're doing when you factor across the rows and up the columns is you are doing the factoring of the pairs. So box method and factoring by grouping, they kind of sort of do the same thing in a way, just a different method of getting there. And then there's another method a tried and true method called slide, divide, and reduce. Now, most people just call it slide and divide. Matter of fact, there are other videos on YouTube that talk about slide and divide. However, this step of reducing is so critically important that I am trying to change the name to slide, divide, and reduce. Now, the beauty of slide, divide, and reduce is the name tells you exactly what to do. So what I'm going to do is I'm going to go through 3 examples with you, and in these 3 examples I'm going to go through each of those 4 methods so that you can decide which method you like the best. You do not have to do all 4 methods. You don't even have to know all 4 methods. You're going to settle on the method that you like the best, but in each of these 3 examples I'm going to show you all 4 methods so that you can kind of decide which one you do like the best. Now, I've got a 6c squared plus 7c plus 2. And remember, I always look first to see if there's something common I can divide out before I do anything else. I can take c's out of here, but not here. I can take a 2 out of here and here, but not here. So there's nothing common that I can divide out. So I'm most definitely headed for this double parentheses, and I'm going to eliminate half my guesswork with these signs. Remember, that back sign here tells me whether they're the same or opposite. This says they're the same. Now I need to decide, are they both pluses or both minuses? This tells me both pluses. So I'm going to put a plus here and a plus here. Now I'm going to split this into the front 2 slots, but notice it's not a 1. So I have a couple of options. That 6 can either split up as a 2 and 3, or it can split up as a 6 and a 1. Here's where that guesswork is going to come into play. However, these 2 here will multiply to be 2. I'll split the 2 into the back slots. Now I don't have a lot of guesswork because there's only one way to split up a 2 as a 2 and a 1. So the c squared most definitely splits up as a c and a c, and I've already made this a little too snug, so let me spread that out a little bit. So I'm going to have a c here plus, and I'll put a 2 there, c here and a plus, and I'll put my 1 there. Here's where the guesswork comes in. I can either try the 2 and the 3, or I can try the 6 and a 1. I'll give the 2 and the 3 a shot. So I'll put a 2 here, and I'll put a 3 here, and then I just need to check my outsides and insides to see if this actually works. So recall that when I check FOIL, I don't have to check the full FOIL because I guarantee 2c times 3c will give me that 6c squared. That's how I picked a 2c and a 3c. I guarantee that the 2 and the 1 will multiply to be a 2. So it's outsides and insides that I'm worried about. Out here, I'm going to get a 2c. In here, I'm going to get a 6c. Do those combine to be the 7c that I wanted? No, they don't. So I need to try something else. Now, before I toss the 2 and the 3 out and grab the 6 and the 1, it would be a good idea to switch things up before you throw them out. I've done this before where I've worked on it for hours, no, not hours, but for a very long time, and I threw my number combination out too fast, went through all the other number combinations. All I had to do was take these and switch them up. So before I throw it out, like I said, I'm going to switch it up, call this the 3 and this the 2. Now on the outside, I've got a 3c, and on the inside, I've got a 4c. Do those combine to be the 7c that I wanted? Yes, in fact, they do. So I know that this is the right combination, and this is the correct factored form. Now, if the 3 and the 2 didn't work, then I could certainly throw them out and grab the 6 and the 1. Now, there wasn't too much guesswork with that. That wasn't too bad. But let me go ahead and show you what factoring by grouping looks like. So like I said, with factoring by grouping, what happens is I take this middle term here and I split it into 2 terms. Now, the way that I figure out how to split it is I'm going to take this 6 and I'm going to multiply it to that 2. I'm going to multiply the 6 times 2 to get a 12. And so what that tells me is I want 2 numbers that are going to multiply to be 12, and those 2 numbers are going to add to be this 7 in the middle. Because remember, I'm taking the middle term and splitting it into 2 terms. So whatever the 2 numbers that are going to be here and here, they need to add for 7, but they need to multiply for 12 because I'm going to take the first coefficient and multiply it to the back coefficient. Multiply for 12, add for 7. That's a 4 and a 3. So that means I'm going to take my 6c squared, but I'm going to take my 7c and I'm going to split it up as a 4c and a 3c. I'll keep the first term, I'll keep the back term, but I'll take that 7c and split it up like this. So now what I've done again is created a 4 polynomial. With that 4 polynomial, I'll pair these up and pair these up. I will factor this pair, and look for that common parentheses. So as I look at this pair, I say, what's common to both? Well, I can certainly divide a 2 and a c out of both of them. When I divide a 2c out of here, I'm left with 3c. When I divide a 2c out of here, I'm left with 2. Now, there's nothing common I can divide out of here, but notice that if I pair that up like this, there's that common parentheses. Remember, I've got 2 very funky looking terms, but there they are, right in here, right in here. Both of them have that common parentheses, that 3c plus 2. I'm going to take that common 3c plus 2 out, and I'm going to write in a parentheses what's left. When I take the 3c plus 2 out of here, I'm left with 2c. When I take the 3c plus 2 out of here, I'm left with 1. And that is what I have up here exactly. So like I said, factoring by grouping takes the middle term and splits it into 2 terms. Now that is how the box method will start. It will start the exact same way as factoring by grouping. I will take the middle term, split it into two terms. The way that I'm going to figure out how it splits is I'm going to take the front coefficient and multiply it to the back. So 6 times 2, again, let me write it this way, hold on. Oh my goodness, what a mess. Here we go. 6 times 2 will give me 12. So that means when I split this up, I want those two numbers to multiply for 12, and they are going to add for a 7, because I want these two terms to add for that 7c. That again is that 4c and that 3c. But here's what I'm going to do now. I'm going to keep that front term, and I'm going to keep that 12 like I did up here. Take my 7c, split it up as a 4c and a 3c. But now, instead of pairing these up and pairing these up, I'm going to take these four terms and I'm going to put them in a box. Maybe the box is a little too tall here. Let me shrink down a little bit. There we go. There's my box. So I'm going to put my first term up here in the upper left-hand corner, and then I'm going to snake my way around the box. So my 4c will go here. My 3c will go down here, and my 12 will go here. And then what I'm going to do is I'm going to factor across the rows and up the columns. As I factor across this row, what's common to both? That's a 3c, which is what I did right here. I looked at both of these two, there they are, and I said what's common, and I factored it out. Whoops, not a 3c, I apologize, that should be a 2c. And then I'm going to factor across here, and I'm going to say what's common to those? A 3. And now what I'm going to do is I'm going to go up the columns, and up through here I'm going to say what's common. Both of these have a 3c. And I'm going to go up here, and I'm going to say what's common to these. Both of them have a 4 in common. Oh my goodness, it's a 12. It's a 2. I am so very sorry. My humblest apologies. So as I factor across here, there's nothing common that will factor out, and it should be a 1. I am so very sorry. And then when I factor up here, I get a 3c. And again, when I factor across here, that's where I was stuttering. I was like, wait a minute, that was right here, and there was only a 1 that I could divide out. Now when I go up through here, I get a 3c. Factor up here, they both have a 2 in common. That gives me that 3c plus 2 that was in that common parentheses. So once again, the answers are on the outside of the box. I get my 2c plus 1 that you see right here, and I get my 3c plus 2 that you see right there. And same thing up there. So again, box method starts like factoring by grouping. I take my front coefficient, multiply it to the back, and that means I want two numbers that are going to multiply for that product. They're going to add for what that middle term is, so that I can take the middle term and split it up. Then I put the 4 terms, snake them around the box, factor across the rows, factor up the columns. Now, last method is slide, divide, and reduce. The name tells you exactly what to do. So the first step is to slide. You slide that front coefficient to the back by multiplication. That should sound familiar because that's exactly how you started factor by grouping. That's exactly how you started the box method. All three of these methods start the same way. Front coefficient multiplied to the back. Here's where we take a detour though, because when we do this, here's the slide. When we do this, this creates a trinomial that's fairly easy to factor, because notice I have a leading coefficient of 1. When I have that leading coefficient of 1, I'm going to go ahead and set up my double parentheses because I know this will split up as a c and a c. Here again, signs are the same, both pluses. And now I want two numbers that are going to multiply for 72. They are going to add up for a 7. Two numbers that multiply for 72 and add up for a 7 are going to be a 9, no, not 9 and 8. It's going to be, hold on just a second here. Oh my goodness, I called it a 12 again. Oh my goodness, I'm really struggling here. I apologize. 6 times 2 will give me a 12. Now I want two numbers that are going to multiply for 12 and add for 7. There's a 4 and a 3. I am so sorry. Okay, so now remember what I slid out. It doesn't just miraculously disappear. This is not magic, it's math. So I need to undo that multiplication. The way you undo multiplication is you divide. So what I slid out by multiplication, I'm going to divide it back in. So here's where the divide comes in. So I'm going to divide that 6 back in. I'm going to divide it into this number, and I'm going to divide it into this number. Now, like I said, I'm calling it slide, divide, and reduce because the step of reducing is critically important. I'm going to reduce this fraction and reduce this fraction. So 4/6 simplifies to 2/3, and then 3/6 simplifies to 1/2. Now, at this point, we don't have fractions whenever we factor, but you know how to clear out a denominator of a fraction. I'm simply going to multiply this binomial by that denominator. So I'm going to take this c and multiply it by 3, which gives me 3c. I'm going to multiply 2/3 by 3, and that will give me a 2. So I get 3c plus 2, which is exactly right here. And then on this one, to clear out that denominator of 2, I multiply this by 2 and get a 2c. Multiply this by 2 and I get a 1, and that gives me my 2c plus 1. So you can see that in all 4 of these methods, I'm getting the same exact set of factors, just 4 different ways of getting there. Now let me reiterate. The step of reducing in slide, divide, and reduce is critically important because what if I didn't simplify here? What if I didn't reduce? Then what happens is I multiply by 6 to cancel that denominator. I get a 6c plus 4, which is definitely not right. And here I would get a 6c plus 3, which is definitely not right. So that step of reducing, like I said, is critically important. Now, let's try a couple more examples just to make sure we get really good at this. So I'm still going to do, like I said, all 4 methods just to make sure you feel very comfortable with all 4 of them. Enjoy this beautiful West Virginia scenery as I really struggle to erase this board because it does not want to cooperate with me at all. Okay, another example here. We've got a 3x squared plus a 2x minus an 8. And so yet again, what I'm going to do is always look first to see if there's something common that I can divide out before I do anything else. And there is not. I can take x's out of here, but not here. I can take 2's out of here, but not here. So I'm ready to go for that double parentheses. Let's go ahead and start with our old guessing check, for those of us who are guessing checkers. So I'm going to head for that double parentheses. And remember, I'm going to eliminate half my guesswork with those signs. This back sign is telling me that they are going to be opposite signs. One's a plus, one's a minus. This x squared splits up as an x and an x. Now, the nice thing is this 3, there's only one way to split up a 3. It's a 3 and a 1, and that's the only way that I can do it. So that helps tremendously. But now I have that 8. I've got a couple of ways that I can split up the 8. I can do an 8 and a 1, or I can do a 4 and a 2. So I'm just going to grab something and hope it works, and if it doesn't, I'll switch it up. So let's try that 8 and that 1. Put the 8 here and the 1 here. Now remember, I don't have to check the full FOIL because I guarantee 3x times x is 3x squared. I guarantee 8 times negative 1 is a negative 8. Outsides and insides is what I'm worried about. Out here I get a negative 3x. In here I get a positive 8x. That gives me a 5x. That's not even the right number. Now remember, if it's right number, wrong sign, just switch those signs around. This isn't even right number. So I need to switch things up. Now, I can switch the 8 and the 1. Don't switch this and this, because that'll just get you right back to these. Only switch one set. And remember, switch it up before you toss it out and grab something different. It might be sitting right in front of your face. So now out here I get a negative 24x. And in here I get a positive 1x. That gives me a negative 23x. Still, definitely not the right number. So switching those signs is not going to help at all. I'm ready to toss out the 8 and the 1 and try the 4 and the 2. So let's put the 4 here and the 2 here. Now on the outside I get a negative 6x. And on the inside I get a positive 4x. That gives me a negative 2x, which, hey, I have right number, wrong sign. Easy to fix. Just switch those signs. Here's my negative Here's my positive. Now on the outside I get a positive 6x, on the inside a negative 4x. That gives me the positive 2x that I wanted, so I know, yes, here's the right answer. All right, so some of you, even though that wasn't that much guesswork, but some of you are probably already exhausted with guess and check. Let's take a look at factoring by grouping. Recall, what it does is it turns this into a 4 polynomial by splitting up that 2x. To figure out how to split it up, I'm going to multiply that 3 and that negative 8, and 3 times negative 8 is a negative 24. So I want two numbers that are going to multiply for that negative 24. They are going to add up or combine to be that positive 2. So those two numbers are going to be a positive 6 and a negative 4. Because positive 6 times negative 4 is a negative 24, positive 6 and negative 4 will combine up to be that positive 2. So therefore, that means I'm splitting this up, keeping the front term, splitting up that 2x as a 6x and a minus 4x, because 6x minus 4x does combine to be a 2x. I'm simply taking my trinomial, turning it into a 4 polynomial, so that I can pair these up and pair these up. Now, when I pair these up, I'm going to look at them and I'm going to say what's common that I can divide out. I can certainly divide a 3 and an x out of both of them. Divide the 3x out of here, I'm left with an x. Divide the 3x out of here, I'm left with a 2. Now I'm going to look at this pair and I'm going to say what's common that I can divide out. Certainly a 4, and we've seen this before where if they both have a negative, probably divide that negative out as well. Divide a negative 4 out of here, I'm left with an x. Divide a negative 4 out of here, I'm left with a 2. There's those two funky looking terms where I've got that common parentheses in both of them. So I'm going to divide that common parentheses out, the x plus 2. When I divide it out of here, I'm left with a 3x. Divide it out of here, I'm left with a negative 4. And you can see that that's what I have up here. Granted, the 3x minus 4 is in the back, and here it's in the front. But remember, you can take your parentheses and you can switch them up because it's parentheses times parentheses. Multiplication's commutative, so it doesn't matter if the parentheses is here or here. I'm going to get the same result either way. Now let's take a look at that box method. Recall with box method, it starts the way factoring by grouping did. I'm going to take that 3 and multiply it to that negative 8 to get that negative 24. So that means I want two numbers that are going to multiply for negative 24 because that was a product there, but they are going to add up to be the middle term because I want them to combine for that middle term. So once again, that's that 6x and that negative 4x. So I'm going to keep my front term of 3x squared plus 6x minus 4x because these two combine to be that 2x. But now instead of pairing them up like I did by factoring by grouping, I'm going to put them inside of this box. So I'm going to put my 3x squared up in the upper left-hand corner, and I'm going to snake my way around the box. The 6x goes here, the negative 4x goes here, and the negative 8 goes here. I'm going to factor across the rows and up the columns. As I go across these rows, I can divide a 3x out of both. Divide across here, I can definitely take a negative out and a negative 4. When I go up here, both of them have an x in common. And when I go up here, both of them have a 2 in common. Now, sometimes we get confused about whether you should take a negative out or not. But recall that back up here, that told me opposite signs. So if I factored a negative out of here, I better not factor a negative out of here. And that gives me my answer of 3x minus 4, which is right here, and my x plus 2, which is right here, giving me the very same answer, just a different method of getting there. So now let's take that slide, divide, and reduce. Recall that first step of slide means take that front coefficient, slide it to the back by multiplication. Here's my slide. And when I do, that creates a front coefficient of 1. And now I've got something that's pretty easy to factor into a double parentheses because of that front coefficient of 1. I'll split it up as an x and an x. Once again, opposite signs right here. One's a plus, one's a minus. Two numbers that will multiply for 24. They are going to subtract for a 2. Multiply for 24, subtract for a 2. That's exactly how we got these and how we got these. So that's that 6 and that 4 one more time. And now recall that what I multiplied out, I want to divide back in to undo what I did. Here comes the divide. So that 3 that I multiplied out, divided in here and divided in here. And now that all critical step of reducing. So I'm going to reduce this to an x plus 2. This does not reduce at all, but I can fix that denominator of 3 because I can multiply this by 3 and this by 3. When I multiply this by 3, I get a 4. Multiply this by 3, I get a 3x. So I'll get a 3x minus 4, like you see right here, and my x plus 2 is right there. So once again, all 4 methods will get me to the same right answer, and you don't have to know all 4 methods. You pick the one you like, and you go with that one. So just to make sure we feel completely comfortable with this, let's try one more example. Again, enjoy that West Virginia scenery. The board seems to be erasing a little bit better now. Praise the Lord for that. This board's making me crazy. All right, one more example. So we have a 5p squared minus 22p plus 8. And so once again, I'll start with my old guessing check. But recall, before I do anything at all, I'm always going to look and see if there's something common that I can divide out before I do anything else. I can divide p's out of here, but not here. A 5 out of here, but not here. So there's nothing common that I can divide out. I am headed for that double parentheses. So now, heading into the double parentheses, I'm going to eliminate half my guesswork. This back sign here tells me signs are the same, both minuses. Now, the nice thing here is that 5p squared, there's only one way to split up a 5. It's a 5 and a 1. So I've got a 5p and a 1p. And now what I'm going to do is I'm going to find 2 numbers that will multiply for 8. Notice the sign, well, actually multiply, I'm splitting up the 8. So once again, I've got an 8 and a 1, and I've got a 4 and a 2. I'm just going to play with the numbers until I get the right combination. So I'll try the 8 here and the 1 here. Again, don't worry about the front. Guarantee it's a 5p squared. Don't worry about the back. I guarantee it's a positive 8. It's the outside with that negative 5p and the inside with the negative 8p that I'm worried about. But that gives me a negative 13p, which is not what I wanted. But before I throw out the 8 and the 1, we'll switch it up and call it a 1 and an 8 like this. Now on the outside I get a negative 40p, and on the inside I get a negative 1p, and that gives me a negative 41p, which is most definitely not what I wanted. Now I am ready to throw out the 8 and the 1. Let's try that 4 and that 2. So now on the outside I get a negative 10p, and on the inside a negative 4p. That gives me a negative 14p. Whew, not quite. All right, switch up the 4 and the 2. Like I said, don't switch these and these. That'll get you right back to the same number combination. Only switch one set. And this has got to be it because I'm out of combinations. Now on the outside I get a negative 20p, and on the inside a negative 2p. Aha, there it is. A negative 22p. So this is the right answer. And for those of you who are completely exhausted by guess and check, we do have factoring by grouping. So what factoring by grouping does, again, is it starts off and says, let's multiply these, that 5 times that 8, to create a 40. So I want 2 numbers that will multiply for 40. They're going to add for that middle one, that negative 22. So multiply for 40 and add for 22, that is going to be a 20 and a 2. So that means I'm going to split this up as a negative 20p and a negative 2p. Because remember, I want these two to combine to be their middle term. It's just this multiplication here allowed us to figure out what number combinations to get. So now I'm going to pair these up and pair these up. I'm going to factor this. Both of them can be divided by a 5p. When I divide that by a 5p, I'm left with p. Divide this by 5p, I'm left with negative 4. And the same thing here. Keeping in mind, I want a p minus 4 inside that parentheses. So as I divide that 2 out, I really want this to be a positive p. So that tells me, let's go ahead and divide that negative out with it. So when I take this and divide by negative 2, I get a negative 4. Positive 8 divided by negative 2 is a negative 4. Here we have those two funky looking terms, here and here. And notice that in both of them, that common parentheses, that p minus 4, I'm going to divide that common parentheses out. I'm going to write down what's left. 5p is left here, minus 2 is left here. And you can see that's exactly what I had up there. Even though 5p minus 2 is up front here and it's in the back here, it's okay. It's the same thing. So now let's take a look at that box method. That again starts the same way and says let's take that 5 and multiply it to the 8 to get 40. And so that means that I want two numbers that are going to multiply for 40 and they are going to add up to be that negative 22. Starts the same way. So those two numbers that multiply for 40 and combine for a negative 22 are going to be that negative 20 and that negative 2. So I'm going to take that 5p squared minus 20p minus 2p, because I'm taking this and splitting it into those two terms, negative 20p and negative 2p combined to be a negative 22p. Very important that you understand that when we take this and split it into this 4 polynomial, I'm not changing the value at all here, because this still combines up to be that right there. I'm not changing value, just its looks, because this look is going to be easier to factor. And now what I'm going to do again is I'm not going to pair them up, I'm going to put them inside that box. So my 5p squared goes here, my negative 20p goes here, my negative 2p goes here, and my positive 8 goes here. And I'm going to factor across the rows and up the columns. When I go across this row, I can take a 5 and a p out of both. When I go across this one, I can definitely take that 2 out. Now when I go up this one, I can take a p out. And when I go up this one, I can take out a 4 out of both of those. Now again, if it's a little confusing as to do I take the negative out or not, just remember, same sign, both minus. So that tells me, oh yes, let's take that negative out with here, let's take that negative out with here, so that I can get my 5p minus 2, like you see right here, and my p minus 4, like I see right there. And now finally, let's try that slide, divide, and reduce one more time. So I'll start with my 5p squared minus 22p plus 8. I will slide that to the back by multiplication, and that number should be familiar because there's that 40 again. And that should be familiar because as I try to split this up into a double parentheses, I'm going to split it up as a p and a p. And these signs are going to be the same, both minuses. This is all sounding very familiar. Two numbers that multiply for 40. Oh, there we go. And they're going to add up for a negative 22. There we go. See, it's these same number combinations. It's just different ways to get to those number combinations. So yet again, that's going to be a minus 20 and a minus 2. So here was the slide, here comes the divide. Here was the slide, here comes the divide. And so now what I'm going to do is take what I multiplied out, I'm going to divide it back in. It's not magic, folks, it's math. So I got to keep that math contained. So I'm going to divide it in right here, and I'm going to divide it in right here. And here's that very critical step of reducing. So important that you reduce. 20 over 5 reduces to 4. Hey, there's that p minus 4. And now this one won't reduce, but remember, I can clear out that fraction. I can multiply both of these by 5. When I multiply this by 5, I get my 5p. Multiply this by 5, I get my minus 2, and I get the very same answer. So hopefully you're feeling maybe not confusion, but freedom. Because like I said, you don't have to know all 4 of these methods. And there's other methods that are out there on YouTube that you're welcome to look at. These are just the 4 that I'm proficient at and can show you. But you have freedom. Pick the method you like and go with that method that you like. So hopefully that helps, and have a great day.